So I have a nice prepared solution for this. In this project, we will use the well-known Microsoft Nougat packages. Especially, we will need the Microsoft ML.vision. Maybe the Microsoft ML is transitively included in this project. So we will need the Microsoft ML.vision, the Microsoft ML.image analytics, and the Microsoft ML MKL. This is a library provided by Intel, and it is, as far as I can remember, this is the mathematics kernel library or something that will be uploaded to the GPU, and this library can use the GPU to do some image analysis with means of TensorFlow. So this project uses the TensorFlow library, which is provided by Google, and we need to use exactly this version. So if you specify any other version than this 2.3.1, then it just won't work. Be careful. I also downloaded the training images. These training images are provided by Google, and you can see that there are nice pictures about flowers and other flowers and roses and flowers and other flowers. So we have a lots of input images for training, and let's check the code itself. Let me just close this one because it is not very interesting in our case. This code is organized a little bit differently than the previous one. It is just one big file, and it just creates the pipeline, the pre-processing pipeline, training pipeline, post-processing pipeline, and then just tries to determine what on the picture is. So let's start in the beginning. First, we need to create the ML context. This ML context object contains everything. We can set up the logging. It will just provide some useful information. And we can load the images not just from CSV files, but from actually any enumerable. So what we create here is just to get files from the training images folder. We just load everything and select, and we just map these files to image data. It is just a class, and the image data is defined here. It just contains the image path and the label. So the image path is just the file name, and the label is just this daisy in this case. So if we have this image and it has daisy in the parent folder, then the label will be daisy. So simple. Print out how many images we have loaded, and we load all the data from this enumerable. Okay, our pipeline is very, very simple. You can see that we have only few steps. We need to map the values into keys. So the label, which is the directory name, the super directory name of the image, will be called label as key, so it will be just the unsigned integer, and we load the image based on the image path. So we just provided the image path here, and there is a transformation step that can load the image directly from an image folder. but actually the training image folder name is contained by the path, so we don't need to specify anything here. So we just load the image into a completely new column called image. So the image will contain the binary format or the image in raw format. This step is very, very smart because it not just loads the image but also preprocesses it. So extracts the pixels and the RGB values from the picture. So when we start training the model, then everything will be prepared. The feature column will contain only the image, so we don't need to concatenate input values because the input value will be only the image. And we provide the label column name, the label as key. The label as key is just the name. So if the training algorithm will see this picture, this I don't know what kind of flower it is, then this side, or it will just save that this is a daisy. Okay. In the end, we will need to convert the predicted label, which is the daisy in our previous case, back into a string. So this is unsigned integer, and we need to convert it back to string format because, you know, we are much better at reading texts than integers. So our pipeline contains a preprocessing step, a training pipeline, and the post-processing. It was divided into 3 parts. Okay, we will train our model, and we can save after the model is trained. Actually, this part takes more than 1 hour in my Lenovo MacBook. So maybe, as I have done this step previously, you can see that my model.zip is here. So I did it previously. Maybe I just will comment this line because it just takes so much time. And also this one. You can download this code and you can run this code on your laptop if you want, but it is just so time consuming, and it actually doesn't make too much sense because they are flowers, so they don't change. If we have a model that was created by somebody, we just need to consume it. We don't need to train our models always. It is just not necessary. Of course, if we have special data, then we can train our model, but most of the cases it is just unnecessary. So what I will do is to load my previously trained model and do some predictions. As I mentioned previously, this create prediction engine is strongly typed, which means it has an image data as an input, and it will provide the output in this output model. It is very similar to the input data. It just derives from the input data. It is not necessary to derive from the input data, but sometimes it can be very useful. We will provide the result in this predicted label property as a string, but of course I need to specify that the column name will be this one, and we will do some post-processing, but it is defined in the pipeline. We also provide the score value. Sometimes the deep learning algorithms can tell how confident they are about this score, but it is not 100% necessary. So when we do the prediction, we need to provide the image data. The only thing we need to provide in this case is is the image path. Because if we call the predict here, then it will load the image from the image folder or from the path we specified as argument 0, but we will check what this image is. It must be a rose, or at least we expect this image to be a rose here. Let me open it. What sees the prediction engine? Okay. Okay, so when the prediction engine sees this picture, then we expect it to return with the string roses. As I mentioned earlier, I just don't want to retrain my model because it is very, very time consuming. So let's start in the beginning. Okay, let's load. Oh, maybe we don't want to debug all messages. We can just come here. Very good. So let's load the model. If everything goes well, then we can see lots of data here. Create prediction engine and do some predictions. Very good. And let's see, image path. Okay, this is the image path we provided. Roses, very good. Then it sees that the image is a rose, and oh, it is quite confident that it is a rose. So 99, more than 99%. Very good, very nice.